Hello, good morning, good afternoon, good evening, everyone, and welcome to this Innovation Talk Let's Exchange series. I am Caroline Deneuve, a Global IoT Marketing Manager at Schneider Electric. So tell me in the chat, who is here to learn more about smart building and how you can bring your business to the next level? All right, so who do we have with us today? Exciting to have you all. All right, I can see a lot of excitement here. Nice to be with you. All right, so I will ask you the first question of the session. Tell me in the chat, how much time do you think we are spending in buildings? All right, I cannot see you answer. Just let me a quick second. I need to refresh my page and I can see you. All right. Hi, Silvio. Hi, Brido. Hi, Christophe. I can see everyone's here. Okay, tell me in the chat, how much time do you think we are spending in buildings? Do you think we are spending 50%, 10%? Wow, you guys are on fire. I can't even keep up. All right. Hi, Enrique. All right, so let me tell you guys, we are spending 90% of our lives inside buildings, whether it is your home, commercial buildings, schools, hospital, hotel. So if you thought the answer was 100%, I really suggest you to take a step outside, but not just yet. Stay with us. So now you understand it's very crucial to bring in operational efficiencies and offer a building that will regulate itself for its occupants. So to give you some insight, we are spending and we are facing a massive inefficiency. And in a study revealed 82% of economic potential in buildings remains untapped. So design is really at the core of thriving to be smarter, faster and intuitive. So who doesn't like the idea to step in a fully automated building? You don't have to worry about turning on your equipment. And on top of this, you will save money and you will also prevent downtime and failure. So this is what you can deliver your customer today. And now we are going to talk about how collaboration will be your key success factor. So let me for this welcome our speaker, our expert of today. I have with me Schneider Electric Strategy and Innovation SVP, Mark Nezet. Next up, we have the CEO of IGE and Alpi, Alain Di Crescenzo, and Don McLean, who is the founder and CEO of IES Limited. So you can use the chat along the session to ask us your question, and we will be answering them at the very end. All right, I think it's time to move to the first question. And I always like to start the session with a question of what is. So Mark, can you tell us what is smart building? And you guys can also share and let us know in the chat section your own definition of a smart building. So Mark, over to you.
Thank you, Caroline, and thanks a lot to host us today for that exciting session. And if you would allow me not to start by answering your question on what is a smart building, but first talking about why do we need a smart building before talking about what is a smart building. So why do we need a smart building? So first of all, I think at Schneider Electric, we are definitely carrying a responsibility on climate change mitigation, facing the fact actually that 80% of the carbon emission are related to energy consumption, knowing as well that in the past 100 years, we multiplied by 10 our consumption of energy. And if we don't do anything, this century will multiply by 4 our energy consumption. And last but not least, building and construction counts for 39% of carbon emission in the world. So I will repeat because we are here to talk about buildings. Buildings and construction count for 39% of the carbon emission worldwide. So if we were dreaming about another reason to be here together and to talk about how we can mitigate that, we could not get a better, let's say, reason to gather together. Then we are lucky because we are helped to bring solution thanks to 2 major disruptions. One is the energy transition, and the second one is a digital transition. The energy transition will give us solution towards more renewable, at the same time, the digital transition will get us empowered to do more conscious choices, intelligent choices by better control. So now I think I answered together with you the why, and I would suggest to move to the what. What would be a smart building? And I think I would define easily a smart building as a mean to reach three very important topics. First, efficiency. Second, user centricity. And last but not least, sustainability. By efficiency, we believe actually by retrofitting, modernizing existing building, we could get 30 to 50% efficiency into the energy footprint. We believe as well that by designing properly new buildings, we could reach actually 25 to 45 better efficiency into the HVAC equipment, as just an example. We believe as well that when designing new buildings or modernizing existing buildings, we could have a better planning of the real space usage, as we believe more than, let's say, 30 to 50% of the space in buildings is not properly used. User centricity, as we believe we need to give buildings that are, let's say, providing well-being to employees, that are as well providing a proper people engagement towards the work they have to do inside buildings, but for as well shopping malls, for other type of different, let's say, businesses, we need as well to supply business continuity for customers, for shoppers, for users within buildings. Last but not least, in terms of sustainability, no doubt that a smart building has to serve a net zero emission objective. And that is a very strong statement that we need collectively to take. So this being said, I would say that we are pretty lucky to be here together, because guess what? There will be no smart building in the real life without a smart building being designed. Meaning that to have well thought about, let's say, what is making a building efficient, what is making that building user-centric, what is making that building sustainable. So I believe collectively we could not drive a better, let's say, agenda for us today, thinking that, let's say, the digital twins start first by having a digital design of a smart and efficient building.
Thank you, Mark. So I can see a lot of definition in the chat, and it's very interesting to see that everyone has its own perspective on the topic. And I really think it depends on the role you have among the life cycle and the challenges linked to your daily work. However, one of the common aspects that everyone, and I really say everyone, should be looking at today is climate. We are facing a worldwide climate urgency, and companies need to engage in making our world more decarbonized. So Don, as an energy modeling software company, how do you deal with this challenge? How do you integrate with these requirements for your end user project definition?
I think, first of all, I would say that I thought Mark's definition of smart buildings was excellent, because it actually is one that I believe strongly that we've got to look at this from a sustainability and a climate change perspective. And my company, IES, has been going for 25 years. We have a core technology that people use to design buildings throughout the world. And we estimate that with the people using our software, we've got over 1 million medium to large buildings that have been developed or created through our software. And we estimate that the savings made using our software in that exercise account to about 32 power stations being built. So we have saved a lot of power stations, but to some extent it's still not enough. We've got to do an awful lot more. I'll come back to that. But I think for us, the big exercise is now, the terminology now has helped us. People talk about digital twins. And I think that we've got a very strong and powerful digital twin. And with that, we've actually digitized physics. And with that, our model captures everything that goes on in terms of the heat flow and the conduction and the radiation, the convection within inside a building. So we capture all of that in our digital twin. And what we can also do is within our system, we have the equivalent of a virtual BMS and a virtual sensors. So the virtual BMS in each room in the building, and for the HVAC system, we define how it's going to operate, just in the way that you would do in a BMS. But also what happens is that in each room, we record hundreds of bits of information compared to what would normally be done. So we're looking at the surface temperatures and the solar radiation information and the air temperature, and the mean radiant temperature and the moisture content. We capture all of that information in our digital twin. And this means that we can really powerfully and accurately predict how the building is performing and how to make it perform better. So it's used a lot in iterative exercises. What we're also doing is to enhance what we do, because lots of buildings don't have good recording equipment, is we've been experimenting with IoT devices, LoRaWAN, things like that, to try and see how we could look at buildings that don't have BMS and what you could do there. But I think that this is a major situation with which, through smart buildings that are sustainable and are getting to as close to net zero as possible, I think that's the future that we've got to take the built environment.
Thank you, Don. So now, Alain, do you want to share a little bit more about the challenges that we are facing in the building industry, and let us know in the chat the challenges that you are testifying in your daily work?
First of all, thank you, Caroline, for your invitation. First, Caroline, the success of a smart building lies in its very early stage definition, so what you call at the design phase. For this reason, I would like to share with you the challenges that are the first ones that the designer will be facing. Okay, and in this context, we can say that there are three main challenges that they have to address. The first one is for the end user to frame and specify their need for the smart building they want to design or to build. And of course, to facilitate this kickoff, the designer needs to be supported by efficient tools and methods to easily capture the requirement. This is the first stage, and to propose design solution and predefined architecture that match with the different requirements. This is for the first challenge. The second one is the optimization of the design process. Let me go back to you, Mark, when you said that you explained there is no building without having a design process. In fact, there is no smart building without having a smart design process. And here the challenge is clearly to break down the silo where often locked all the actors that work on the design and the build phase. Knowing that every action is built and or depend on the information defined above screen. This is the reason why it's very, very important to have a collaborative process and tools, of course, tools mean software, as well as open format to communicate. And last but not least, because the design phase is only one phase, it's not the end game. The third challenge to address is the capacity to deliver comprehensive as-built design file to be reused and used effectively during the operation phases. They are, for me, the main challenges that you have to face, of course, the design file phase.
So thank you, Alain. Mark, we are slowly moving to smart building for greater energy efficiency, for cost management, prevent default and failure. We definitely need to think big on a project, but we should always start small and scale fast. So can you share a successful use case where collaboration has been a success, and how, and in the chat, you can also share with us your successes.
Yes, Caroline. So let's say before to describe use cases, I would actually maybe set the scene. When we talk about, let's say, when we take the life cycle, let's say we all know that we first talk about design, then we talk about the build phase, and then we talk about operate and maintain, and we conclude with the circularity topic, which is the end of the life of a given building and installation. So by focusing only on design, I would say that it represents really the foundational stage to any smart building, as we said. It means that the design is extremely important in terms of the way we set the ambition and the way we, across the different stages that I will mention, we have really between the building owner and his consultant, his designer, that they set the scene to make conscious choices on technologies that will be matching an ambition for efficiency, an ambition for users, centricity, and an ambition as well for sustainability. And they will have to stay firm on that ambition, because we see that today it's not always the case. And then we take a workflow, which is usually made of, what we call a conceptual design, followed by a first level of detailed design, and finally ending up to the final detailed design, at that time probably during the general contractor and the different specialty contractors that have to execute what was the ambition coming from the building owner and his consultant. And let's say, after having mentioned that workflow, I can easily describe a few situations, few pain points that I'm sure will resonate with a lot of you. How many cases did you notice that we could lose information between the different stages? Is there a loss of information in the transmitting the ambition, transmitting the exact requirement for efficiency, for user centricity, for sustainability, from an end user to a general contractor, from a general contractor to a subcontractor? How many times did we see that actually mechanical, electrical, plumbing, so the MEP specialties are designed in a silo way, not talking to each other? In how many cases we saw some, specification changing between the general contractor and the subcontractors versus the initial statement or initial ambition that was stated by the building owner? And last but not least, in how many cases we notice that we go usually for oversizing, over-dimensioning? Is it an electrical system? Is it an HVAC system? Is it the redundancy in a building? So all those four statements are really the reality of the pain point. And from those pain points, we can derive very easily three use cases that I could share with you. The first use case is that we could see that by breaking silos between MEP and running softwares that are performing, as an example, collision or clash management, you can really save a massive proportion, at least 30% of the rework during the build phase. We could have as well as, let's say, as a data point that we face a lot in Schneider Electric, having a very strong position in a data center, that we usually, by doing optimization, the right dimensioning, the right sizing of the powertrain, we save up to 15% of the bill of material into a data center electrical distribution design. Last but not least, and Alain is a good example of that with the software of his company, is that his software, by proper usage of the engineering software, you can save up to 20% labor cost into the panel assembly, into the electrical switchboard assembly. So those are very concrete use cases that we have, addressing different pain points across the workflow in design.
Thank you, Mark. So we are saying that we need to move from traditional to smart building. And this highlights to me a dual need in creating new buildings, but also transforming existing and legacy ones to being smart. So how do you deal with this? How do you digitize an existing building from a new one, Don?
Well, I think to answer that, it's a good question. I think what I'd like to do, Caroline, is give you a couple of facts first. And these are facts maybe you've heard before, but you know, in the UN believe that by 2060 we will have doubled the built environment. So that means that we're talking about an extra 230 billion square meter of construction, which is, if you think about it, is quite a lot. But then to the same extent, in between 2013 and 2015, those 3 years, China used 10% more concrete than the United States did in the whole of the 20th century, from 1900 to 2000. So if you think that the amount of concrete they did in 3 years, it took the States 100 years when they were building all of their skyscrapers, all of their roads, and things like the Hoover Dam and things like that. You know, they're quite astonishing statistics. So if you look at what we're likely to have to build over the next 50 years, there is all of the building stock that's around just now, the majority of that will still be around in 50 years' time. So we need to look at how we make that existing building stock smart. Now, the thing about having a digital twin is, with the digital twin, you can create something that's not there. You can create something that's virtual, and you can analyze it just as if it was operating in the real world. So that's what we allow our customers to be able to do. But the other thing that we need to look at is being able to, and the advantage of an existing building is it might have a BMS or it might have some sensors, and it doesn't cost a lot to put some low cost sensors in to get information. But from that, we can use that sensor information from the existing building to look at how it's performing, to try to optimize its performance from the data, but then to understand the building fully. And we can create, and I mentioned earlier about things like virtual sensors and things like that. So in our virtual model with these virtual sensors, but we can substitute the real data from the building into the model. And that way we make the digital twin much more accurate. We create a hybrid model. And there's methods by which called we can look at decarbonization of buildings. And this can help us be able to predict what's going to happen. We can make much better decisions, much stronger decisions, and getting to this net zero target that Mark was talking about when he answered the question earlier on. So putting all this together, what we're trying to do is kind of provide the how do you do it. There's lots of ways by which people can say this is what you need to do, but it's to have the quality and the quantity of information and to make those decisions. In both new buildings and existing buildings, both have that kind of challenge. And I think it's important that we have the right technology to make buildings more efficient.
Thank you so much, Don. So, Alain, you are the CEO of Alpi and IGXAO, an electrical CAD software editor company. So can you tell us how to implement BIM and why this is a key success factor to design a smart building?
Yes, of course, Caroline. First, to start, let me say that today the BIM potential is still largely untapped. This was a little bit your introduction, and especially in our domain, means in the energy and then electrical domains, which is clearly for IGXAO and LP a real opportunity. Second, BIM is not at all nice to have. It's more and more mandatory if you want to bid on construction project. And third, BIM is not a cost, but a real investment. And every penny invested in BIM design pay off during the build, commission, operate, and maintain phases, the life cycle introduced by Mark. And the return of investment is impressive. The figures are received is that we have about 5 to 10 times the amount invested as payback. Now, if I go back to IGXAO and LP, our BIM strategy is based on providing electrical added value that we call electrical services integrated with AEC, architecture, engineering, construction, modeling software. And we have selected as an IC platform Revit from Autodesk. If I look at the electrical services we provide, we provide software, cloud-based or on-premise, that cover different domains, of which the electrical implementation And here you have different softwares, different solutions with Caneco Implant and Caneco Beam, where we provide a set of features to implant the electrical devices in the 3D mockup, to define the cable pathways, and to route automatically the cables into the pathways. This is for one of the domain, one of the software we have. After, we have software for electrical network calculation, and the number one in Europe is LP from Caneco from LP, and this is for the dimensioning of the protection and the cables. We have also software for schematics and detailed design with the C Electrical software family, and we have the 3D panel design in manufacturing, and here we have C Electrical 3D panel from IGXAO and Office Elect from LP. And here we manage the complete life cycle of the panel from the design to the manufacturer, including the configuration of the panels. At the end of the day, our objective is, of course, to design the electrical part of the installation and the building, but also to deliver what we call its digital twin and its digital notebook. Digital notebook with all the necessary information for the end user, for the maintenance and for the operation. Again, if you want to be successful in the implementation of your BIM strategy, the critical point to address is the communication, or even better, what you call the integration between the different softwares. And of course, this is a clear advantage for IGXAO and LP. Having in the same hand, IGXAO and LP is a clear advantage on market. Lastly, please don't forget that behind tools, of course, we have people. And of course, you have to connect the tools, and you have also to connect and to identify the people. This means all the actors of a building project. I'm talking about the BIM manager, the facility manager, real estate portfolio manager, construction manager, architect, construction designers, and so on and so on. And this is very, very important.
Exactly. Behind the tools comes the people. And I want to try something with you more. So give me a show of hand in the chat. Who is a property developer, a facility manager, a real estate portfolio manager, construction site designer or manager, quantity surveyor? So let me see. Do we have any of those profiles with us today? All right. Let me see. Okay, I can see a few of you. I can see that we have different profiles with us. So see, because today we are reunited as a community of experts, we can connect and ease communication across the actors. The market is getting more and more complex. So finding the entity owning the capabilities to answer your problem, your customer problem, is getting more and more difficult. So what if I tell you that those communities exist and you could already be joining them? Wouldn't that be exciting? All right, so let me see. Do I see a little bit of excitement? All right, so who doesn't like the idea of a permanent place where actors can easily connect, do business together, access a new go-to-market? So Schneider Electric launched a new open ecosystem business platform a year ago called Schneider Electric Exchange. It really aims to facilitate the communities to have a permanent platform and infrastructure to accelerate their business. So Mark, can you share with us a little bit more on the value proposition?
Yes, I can of course, with great pleasure. So Schneider Electric Exchange is, let's say, both at the same time a digital ecosystem and a business platform, and it brings together business experts, innovators, not only actually startups, as well large companies, and so on and so forth. So I would say that while describing Schneider Electric Exchange, I would want to share with you a reality and a dream. The reality is that through Schneider Electric Exchange, you can access today, let's say, a community. You can access today a digital marketplace, and you can get access today to technical resources. So we don't talk about tomorrow. We talk about a reality today. as we get since April 2019 and the launch of Schneider Electric Exchange, we have already 50,000 users. And what those 50,000 users found, first of all, as I said, they will get access to a community, and we already measured 1.5 million pages viewed since the launch of the platform. So that community is made of collaborators, of co-innovators, and so on and so forth. They have an access to a digital marketplace with, let's say, two already metrics that we can share with you as part of this reality. The first one is that we have 300 offers published on that marketplace, out of which 50% are non-Schneider offers. And that should go up in the future. The marketplace is not there to show, let's say, or to display only Schneider. It's made to create a marketplace where you can provide your expertise. You can source as well products or offers from others, but this, let's say, bidirectional purpose of the platform is really there through that marketplace. And last but not least, on the marketplace, you can today access about 150 service providers, and we expect it to increase very soon. Last but not least, in terms of technical resources, you can access today through Schneider Electric Exchange about, let's say, 50 different assets among APIs, software development kits, or data sets of some sort that you could access. So this is the reality of what is today Schneider Electric Exchange. And then if I would mention to you the dream that we have is that we could, through Schneider Electric Exchange, give you a forum where you can really consume or bring your expertise. You could as well expose your offers, get customers, yourself augment your capabilities, and let's say the different features or application you would have on your offer. And the dream we have when we look at the entire community that we address, what we could call actually those smart building activists that should help us to design this building world of tomorrow. We can see the world today made of 3.4 million electricians, engineers and technicians, and about 7 million mechanical engineers and technicians as well. And guess what? There will be no smart building reality without us collectively bringing a design world to those people through Schneider Electric Exchange. So I cannot do nothing else better but to encourage you to discover Schneider Electric Exchange, and I think you will be given the right access to this exchange.support site to get yourself familiar and enrolling yourself on the platform.
Thank you so much, Mark. This is very exciting. Thank you so much for sharing this with us. So now if I come back to you, Don, how will this open ecosystem will facilitate the digital twin?
Well, I think the thing, Caroline, is you could turn around to Mark and tell Mark he does a great job at selling SE Exchange. We're really excited about it. And I think the thing is that where we see it is promoting our technology to the Schneider wider community. But also I think the thing is that this kind of idea of being able to advise and people coming and seeking advice, I think that's important because it allows us to explain what we do, explain to them, what a digital twin is and what it gives it when they're looking at, what does digitized physics mean? And begin to start to look at how you could make your building perform better, the options and the way you could address it. So I think all of those aspects we see as something that the SE Exchange can help us with. I think also the fact in terms of generating revenue, building digital twins for people, managing digital twins, looking after them over decades, that's going to generate a lot of revenue. So there's the design part that we can look at, but I think looking at this also as an ongoing exercise to create nice sticky business for people so that they can generate revenue and provide service where you're actually creating better building portfolios for people, those portfolios are moving towards net zero carbon. I think that's the kind of important thing. And I think where this kind of forum and what we're talking about, I think Schneider are taking the role of leaders. They're putting their best foot forward, trying to do something about this, trying to make something happen. And I think that's the responsibility that companies of Schneider's size have got to take. They need to help drive this deep into the built environment, so that people will start to do something about it. Because as it was said earlier on, time is short. We need to do something about it. And I think this is a good vehicle for attempting to do something about climate change.
Thank you so much, John. So, Alain, your company joined Schneider Electric Exchange about a year ago now. And can you share with us the business benefit you got from joining this open ecosystem business platform?
Yeah, in fact, we joined the platform, let's say, really 6 months ago. Okay, so to be clear, if you look at today's situation, you can say that no software editor alone can bring to the market a full end-to-end and multi-domain value proposition. This is clear. And for this reason, and it's very important for us, and I think also for my colleagues or the other software vendors, to be part of a professional, that is very important, professional ecosystem to access complementary expertise and software components. And in this context, Exchange is a unique opportunity to join, of course, forces and to collaborate. And thanks to Exchange, this is the experience we have with this platform. IGXO and LP are connected with a professional ecosystem, with an ecosystem of experts. That is very important for us to think about the future features that you have to implement in your solutions. We access tools and resources such as kits or API. And for example, we have integrated in our solution, means IGXO and LP, Schneider products, electric and integrators. And this is a significant added value that we deliver to our customers. Thanks to Exchange, we are connected to a software community. And this is very important to facilitate the creation of partnership to build joint customer added value. And thanks again to Exchange, we are also in relation with customer and prospect through collaborative forum. And what is very important is that Exchange includes a shop, and this is very important. And we can, and this is true for IGXO and LP, but also for all the members, we can list and also sell our solution through the platform. And today we have 3 of our solutions on Exchange. We have a C electrical expert, we have a C electrical 3D panel, and we have a connectivity for LP. And to conclude, and to be clear, for LP and IGXO, Exchange is clearly a part of our technical, but also commercial and of course communication strategy.
Thank you so much, Alain. So, Mark, I want to close with a question driving this session, and before moving to QA. So, everyone, you can type in your question in the chat, and we will get to it in a minute. So, to conclude and sum up the discussion, Mark, how can we differentiate by design to win over more business?
So, first of all, as we said, a way to differentiate, first of all, is that we should collectively share a purpose we serve. And the purpose that we mentioned, that building and construction represent 39% of the carbon emission, and we have to address it. We owe it to us, we owe it to our, let's say, customers, stakeholders, we owe it to our children for the future. So that's a very strong, let's say, commitment on the reason to drive a smart building approach. Second, we said that there won't be no smart building without a smart design. It's another way to say that it starts now. It starts with us. It starts with a community that is aiming to design differently in the future. BIM is here to support us. BIM is an underlying, let's say, a statement to say that we need to talk to each other, we need to collaborate, we need to work together. We have softwares to help us to do that right now, and we have a platform where we can converge and share our different expertise, buy expertise from each other, and so on and so forth. And it's called exchange.support.
Thank you so much, Mark. So I'm looking at the different questions that we have. So I have one coming in from Vipul. So how do we provide smart buildings for developing countries to provide a safer environment? So I'm addressing it to you, Mark, but you can share and react as well, Ella and Don.
If you could repeat the question, please. I had an echo and could not hear.
Sure. So it's how do we provide smart buildings for developing countries to provide safer environments?
Okay. First of all, what I believe is that a smart building is not questioned to any geographies. If we all agree that it's let's say a buildings that would fit the purpose of being efficient, of being let's say user centric, and being as well sustainable. I think by defining the level of, let's say, efficiency wherever you are on the planet, whatever is the context of your climate, whatever is the context of the business or the purpose that the building is serving. Is it a stadium? Is it, let's say, a shopping mall? Is it housing? Is it a school? And so on and so forth. As well, talking about the energy mix, that could be different if you are designing a building in Morocco, designing a building for Colombia, or designing a building in Sweden. That's radically different. So I would say that today I would not link to a certain geography, to a certain, let's say, economical development condition, let's say the reason to design or not a smart building. We all have an agenda to carry on that, and maybe Don, you could as well comment on that, because I know that IES, you have experience in decarbonizing buildings in the Middle East as you would have it in Asia or North America or Northern Europe.
I agree with what you're saying there. I think the big problem that we face globally is there's going to be a lot of societies, a lot of countries that are going to develop very, very fast, like Indonesia. Reckon that Indonesia will be the fourth largest economy in 20 years' time. And that's going to require a massive amount of building, just the way that China's going through a massive amount of building. And I think that as these countries start to develop and grow, what we need to try and do is find the methods for them. And I think this is where the wider community, the global community, can start to help people in these countries develop structures that are going to be efficient. And I think that's the kind of the key aspect, because you know, I think efficiency is key to smartness, and it's got to be done. And I think if that is done in a more informative way, people being able to collaborate and so on and so forth, and trying to make their buildings as efficient as possible, then what the hope is that to move them to decarbonize from there is much less than the kind of problems we have at the moment when we're building buildings. And the big flaw we have in design at this moment in time is that we embed in problems, like the performance gap in buildings. So that means that you've got an extra barrier to cross to try to get the building to zero carbon. So I think these are all kind of important issues that we need to address as a global community to try to make the buildings perform correctly in the appropriate environments that they're in.
Thank you both. So I'm having a question from Mathiej. So how does wireless and reliability play into the role of building smart connected buildings? And this could go to Alain.
Yes, of course. If you look at the cabling, the cost of the cabling of a building is very important. And more we are wireless, more you decrease the cost of the building. And also is in terms of implementation, of course, we are the efficiency is very important. Okay, so this is for the we can say the wireless in the building.
I could also maybe comment, Alain, that we, that let's say, if we say, and a bit going back to what Don was telling about his sensing and the virtual sensing, I think wireless allows us, especially on retrofitting, to, let's say, take down the, let's say, the cost and the initial setup cost for an IoT infrastructure. You can really go for multiple sensing and capturing data, increasing your sources of data into an existing building, thanks to wireless technology. We know as well that, let's say, the 5G will be bringing new capabilities in processing data in a wireless environments, especially for multi-site remote operation and later on aggregation of data. So let's say we see it definitely as an enabler, as a facilitator. Then this being said, what we noticed is that in the design stage, usually specialties have been pretty siloed. It means the electrical design capabilities are not necessarily combined with, let's say, the control design capabilities in ultra low voltage as an example. So we need sensing design competencies to be joined with a different subsystem in order to make a wireless and IoT infrastructure natively designed with a different subsystem. And it's not always the case. I don't know if, Don, you have an experience on that you could share as well.
Well, I think if I go back, that what we're doing is we're experimenting a lot with sensors and the information they can get, and trying to look at, because as we all know, there are many buildings that have no sensors in them whatsoever, and it's trying to, it's not about just making the new buildings or the best buildings or the biggest buildings more efficient. It's trying to make all buildings more efficient. And I think the whole thing about sensors and wireless, and we talked about there earlier on about developing countries, these are the kind of things that we can, and that can maybe be used in those buildings to try to make them as energy efficient and smarter and as close to zero carbon as we can possibly get them. So I think that the whole IoT structure works, but I do think also that the word smart is abused in many instances by people, everything's smart just because there's a sensor associated with it, but it's got no function and value. I think it's about using this in an intelligent way and having the right kind of information that's brought to be able to be analysed and to be able to make that particular building perform as well as could possibly be, and trying to aim for the zero carbon for it.
Yeah. And what is very important also for our solution is this: we have been implementing in our solution, is that due to the fact that we have more and more wireless installation and wireless component, we are develop special modules to define the signals, not only the cables. I introduced to you the routing of the cables. Now we work with our solution about how to define the communication, not using the cables, but using the signals. And this is also very important. And I really agree with you, Mark. This the wireless is also very important for the renovation, and we can also have a smart building renovating the old one.
So I have another question coming from Hussein. So over a year, how much energy can you save compared to a smart building? Like, how much do you save for a smart building, and how much do you save from a normal one?
Yeah, I would be interesting to hear data points from Don, but what we know from our side, from different observation and measurement, also from peers, it's 30 to 50% energy saving into let's say what we could call a smart building versus a conventional one. I don't know, Don, your data point on that.
I think one of the things that we're doing a lot with people in terms of trying to help them decarbonize is it's not something you do in one go. You break it over a number of phases because you look at things differently. So these are things called positive energy blocks, where you take maybe say a group of several buildings and they maybe almost compete in terms of the way they use their energy, so that they're not all at the exact same time. And with those buildings, you can then start to operate them in such a way that you might start off looking at, say, how could we make the building more efficient? So you start looking at things like the sensor information, trying to see where you could make the building operate better. Then you then start to say, I want to look at the envelope. And then you could say, I want to look at maybe, say, doing some deeper renovations and things. So you kind of phase it over a period of time, because sometimes what you do is you try to do all at once. Some of the things that you choose might actually fight against each other. They might not complement one another. So by doing it in a phased way, in this way, and we're talking about trying to decarbonize by 2050. So the purpose of doing this is that you by doing it in small bits, you prove the efficiency, and to some extent, the savings you make in the building, you can use to fund the next part of the exercise that you're trying to do. So it's not all an upfront cost. But the savings you can make just from, say, for example, just looking at the data from the building, we found is 10 to 20% operationally. You can improve the building, and then when you start using the envelope, this is where you can then start making a 20 to 40% difference. And then each phase, obviously, you're not going to get the upper band every time you do it, but through this kind of process, you can constantly iterate down to get to zero carbon, or in the instance of positive energy blocks, you're trying to have a net positive energy, which is the kind of thing that we might need from the built environment in order that we can support other sectors of the globe that actually need carbon, because it can be replaced in what they do. So the kind of concept of going for a positive energy block is to kind of meet that potential contingency in the future.
All right, so I have one last question for you. I will actually combine two into one. So the first one is from Chris. He's asking, where do you see AI play in the deep learning of trends and multipurpose utilization like a stadium or North America arena? And then on another question from Shailish, he's asking, now that we are moving to smart building, how do we deal with cybersecurity? So the first one is about AI and the second one on cyber.
I'll pick up the AI one just now, possibly. We use a lot of AI in what we do in order to interrogate the results of both the real data from the building and also the virtual data, and combining them together. In fact, we've actually got a project going on with Schneider at this moment in time, where what we're doing is we're taking some of the information through the Smart Connect function that Schneider have, and bringing it into our software, looking at what the data is saying, and feeding back information about where things could maybe be tuned in the building and things like that. But we can use all of that information into creating the hybrid digital twin that then allows us then to analyse the kind of things that I mentioned earlier with the positive energy blocks, in order to make the buildings as efficient as possible, and we can identify the savings and have much more confidence in the results that you get. So AI can be used in a number of those spaces along the time, replacing data that's maybe missing because a lot of the recorded data might fail for some reason. It's not recorded. We can use machine learning to fill in the gaps. So I think that AI and machine learning is an important aspect, but I think one of the things that AI is not really appropriate for, compared to the likes of having building physics, is with building physics we can actually predict something that's not there, that is purely virtual, whereas AI needs information to kind of do that. So I think that the advantage of new building and also looking at retrofit and how we do it, this is where having a digital twin that employs physics deeply in what it does is very powerful. But it can be augmented when we're looking at how to tune the building, tune the performance of it. AI and machine learning is very effective at that exercise.
Thank you so much, Dan. So I think this will conclude the session. So thank you, everyone, for a very energizing session. Today is really our invitation, not only to register on Schneider Electric Exchange, but also to start interacting and collaborating to own your own success stories. So I know sometimes it can be a little bit difficult to start on a new platform. So from the homepage, exchange.support.com, you will be able to register, but also we'll be able to contact us for support if needed. So thank you everyone for being with us today. We hope you enjoyed this new live format, and we are happy to have the discussion going. And I will see you next month to speak about cybersecurity. Bye-bye.
Thank
Bye-bye.
you.
Thank you very much.
Caroline,
Bye.
good seeing you guys.
Thanks everyone. Bye-bye.